According to the National Electrical Code, changing the designation of a wire by applying electrical tape of a specific color is acceptable. National Electrical Code Article 800.54 states that conductors of a multi-conductor cable must be identified at their terminations by color, marking tape, tagging, or other approved means in accordance with Table 800.54a. Therefore, green electrical tape can be used to change the designation of a white wire to ground. However, there are several important points to consider. Firstly, this should only be done at the end of the wire, where it is terminated. Secondly, the entire length of the wire should not be taped. Thirdly, the tape should be applied tightly and securely. Permanently marking the wire with the new designation is recommended, such as with a permanent marker. Also, this change should be clearly documented and noted on any electrical diagrams or plans. Additional considerations include the use of green electrical tape to indicate other designations such as circuit grounding conductors as per Article 250.119 of the National Electrical Code. White tape is typically used to indicate neutral conductors. Black, red, or blue tape is typically used to indicate phase conductors. It's always best to consult with a qualified electrician for proper wiring and designation changes. The National Electrical Code, or NEC, is a set of standards for safe electrical installation. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is not law itself, but is often adopted by state and local jurisdictions. Article 800 of the NEC covers communications circuits. This includes telephone, television, and data circuits. These circuits typically operate at lower voltages and currents than power circuits. However, they can still be hazardous if not installed properly. Article 800.54 specifically addresses the identification of conductors in multi-conductor cables used in communications circuits. This is important for ensuring that the correct connections are made and that the circuits are safe to work on. Table 800.54 provides a list of acceptable methods for identifying conductors. This includes color coding, marking tape, tagging, and other approved means. Color coding is the most common method. The NEC specifies the colors that should be used for different types of conductors. For example, green is typically used for grounding conductors, white is typically used for neutral conductors, and black, red, or blue are typically used for phase conductors. Marking tape can be used to identify conductors that are not color-coded. The tape should be of a contrasting color to the conductor and should be applied in a way that is easy to see. Tagging is another method of identifying conductors. Tags should be made of a durable material and should be securely attached to the conductors. Other approved means of identification may be used if they are approved by the authority having jurisdiction, which is typically the local electrical inspector. When changing the designation of a wire, it's important to follow the NEC guidelines carefully. This will help to ensure that the wiring is safe and that it meets all applicable codes and regulations. It is important to note that simply applying color tape over the entire length of a wire is not an acceptable practice, as it could potentially conceal damage or deterioration of the wire's insulation. It's also crucial to consider the environment in which the wiring is installed. For example, in damp or corrosive environments, it may be necessary to use special types of tape or other identification methods that are resistant to these conditions. In addition to the NEC, there may be other applicable standards or regulations that need to be considered. For example, some local jurisdictions may have their own specific requirements for wire identification. It's important to check with the local authorities to ensure that all applicable requirements are met. It's also important to keep accurate records of any wiring changes that are made. This will help to ensure that the wiring can be easily identified and maintained in the future. The record should include a description of the changes that were made, the date of the changes, and the name of the person who made the changes. These records should be kept in a safe place and should be readily available to anyone who needs them. The National Electrical Code does not explicitly forbid re-identifying a conductor with tape. However, it's essential to understand the proper application and limitations. You can re-identify conductors, particularly at the termination points, using colored tape if the original insulation color doesn't match the intended use. One common example is re-identifying a white wire as a hot conductor in a switch loop. In this case, you would wrap black tape around the white wire at both ends to indicate that it's being used as a hot wire, not a neutral. The NEC provides guidelines for the color coding of electrical conductors. The purpose of color coding is to provide a quick and easy way to identify the function of a conductor. This is important for safety reasons, as it helps to prevent accidental contact with live wires. The NEC specifies the following color codes for electrical conductors. Firstly, grounded conductors, or neutral wires, must be white or gray. Secondly, grounding conductors must be green or bare. Thirdly, ungrounded conductors, or hot wires, can be any color other than white, gray, or green. The most common colors for hot wires are black, red, and blue. When re-identifying a conductor with tape, it's important to use the correct color tape. For example, if you're re-identifying a white wire as a hot wire, you should use black tape. It's also important to wrap the tape tightly and securely around the wire. The tape should be applied in a way that is easy to see and that will not come loose over time. While using tape to re-identify conductors is generally acceptable, it's not always the best solution. In some cases, it may be better to replace the wire with one that has the correct color insulation. This is especially true if the wire is located in a damp or corrosive environment. When working with electrical wiring, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It's also important to energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician. Electricians are trained to work safely with electricity and to comply with all applicable codes and regulations. The NEC is a comprehensive document that covers a wide range of electrical topics. It's important to be familiar with the NEC if you work with electrical wiring. The NEC is updated every 3 years, so it's important to make sure that you're using the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find the NEC online. In addition to the NEC, there are other resources available that can help you learn about electrical wiring. These resources include textbooks, training courses, and online tutorials. If you're serious about learning about electrical wiring, it's a good idea to take a training course. Training courses are offered by community colleges, trade schools, and other organizations. These courses will teach you the basics of electrical wiring and will help you to prepare for a career in the electrical industry. Electrical work can be dangerous if it's not done properly. It's important to take the time to learn about electrical safety before working with electrical wiring. If you're not sure how to do something, it's best to ask a qualified electrician for help. National Electrical Code Article 200.7 provides some rules about the use of white or grey wire. Generally, a conductor with white or grey insulation is intended for use as a grounded neutral conductor. However, there are exceptions. An exception is when the white or grey wire is used for permanent circuit extensions or modifications. In these cases, the white or grey wire can be re-identified to another color using paint, colored tape, or other effective means at its termination points and at each location where the wire is visible and accessible. Another exception is for internal wiring of equipment. Some equipment is pre-wired with white or grey wire for specific purposes, and these wires don't necessarily need to be re-identified. When re-identifying a wire, the marking must encompass the entire visible portion of the insulation. The color should be durable and easily distinguishable from other colors. The purpose is to clearly indicate that the wire is no longer functioning as a neutral. An important note about green wires: it should never be re-identified for use other than as a grounding conductor. Green wires are exclusively for grounding purposes, and this should not be altered under any circumstances. Also, it is important to emphasize that while taping is permissible, it should be done correctly. And properly applied tape that easily falls off or is the wrong color is not an acceptable method. Always use high-quality electrical tape and ensure it's tightly wrapped and securely fastened. For larger gauge wires, multiple layers of tape may be needed to ensure the color change is readily visible. In industrial settings, wires are often labeled with heat-shrink tubing with printed labels. This provides a more permanent and professional way to identify wires. Always disconnect power before working with electrical circuits. This is a fundamental safety precaution that should never be skipped. Test the circuit with a voltage tester to verify that it is indeed de-energized before touching any wires. Secondly, use insulated tools to prevent accidental shocks. Insulated pliers, screwdrivers, and wire strippers are essential for safe electrical work. Thirdly, wear appropriate personal protective equipment, including safety glasses and gloves. Eye protection is needed to prevent debris from entering your eyes, and gloves protect your hands from electrical shock and burns. Fourthly, never work alone. Having someone nearby can provide assistance in case of an emergency. Fifthly, follow all applicable codes and regulations. Electrical codes are in place to ensure safety, and it's important to comply with them. Sixthly, if you are unsure about something, ask a qualified electrician for help. It's better to be safe than sorry when working with electricity. Always consult the latest edition of the National Electrical Code for the most up-to-date information. The NEC is revised every 3 years, and it's important to stay current with the latest changes. The NEC contains detailed requirements for electrical installations, and it's essential to comply with these requirements to ensure safety. When making any electrical modifications or extensions, be sure to obtain the necessary permits from your local building department. Permits ensure that the work is inspected and meets all applicable codes. When working with older wiring, be aware that the insulation may be brittle or damaged. Handle the wires carefully to avoid causing further damage. If you encounter any damaged wiring, it should be replaced by a qualified electrician. Also keep in mind the proper sizing of conductors is essential for safe electrical installations. The size of the conductor must be appropriate for the amount of current it will carry. Overloaded conductors can overheat and cause a fire. Use the appropriate wire connectors for the type and size of wire you are working with. Improperly installed connectors can loosen over time, lead into poor connections and potential hazards. Grounding is a critical safety feature in electrical systems. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Make sure that all electrical equipment is properly grounded. Also, ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs detect small imbalances in current and quickly trip the circuit, preventing a dangerous shock. Install GFCIs in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or SIs, are designed to protect against electrical fires. SIs detect arc faults, which are dangerous electrical discharges that can ignite flammable materials. Install SIs in bedrooms and other areas where there is a risk of fire. When using extension cords, make sure they are properly sized for the load. Overloaded extension cords can overheat and cause a fire. Avoid running extension cords under rugs or furniture, as this can trap heat and create a fire hazard. Never remove the grounding pin from a plug. The grounding pin is there for safety, and removing it can increase the risk of electrical shock. If you have any questions about electrical safety, consult a qualified electrician. Electricians are trained to work safely with electricity and can provide valuable advice. Always follow the manufacturer's instructions when installing or using electrical equipment. The instructions contain important safety information that you should not ignore. Keep electrical panels and equipment clear of obstructions. This will allow for easy access in case of an emergency. Never allow children to play near electrical equipment. Electricity can be dangerous, and children should be kept away from it. If you see any signs of electrical hazards, such as frayed wires or sparks, contact a qualified electrician immediately. Don't attempt to fix the problem yourself. Regularly inspect your electrical system for any signs of damage or wear. This will help you to identify potential problems before they become serious.